Hello everyone and welcome to my channel. In this video I would like to show you the AWK programming language in FreeBSD and go over a couple of examples. Okay, let's do this. The AWK programming language is a language that was created in the 70s, I think in 1977. It's a simple programming language to write very simple and short programs that manipulate text and numbers, and it processes files line by line, typically. The AWK programming language predates Python and it predates Perl. When you do a FreeBSD installation, this programming language is available in a bare-bones FreeBSD system, so that is pretty cool. In a vanilla FreeBSD system, one of the programming languages you can use to develop software is the shell script, but if you want to process files, I think nothing beats, or it's very difficult to beat, the AWK programming language. Interesting enough, I think AWK is still relevant nowadays, even though most of the software nowadays is being developed with Python. It is very easy to create scripts in AWK. So let's have a look about the syntax of the AWK programming language and let's get busy writing some programs. In your screen you can see a summary of the AWK programming language. Let's have a look at this. Here in this part you can see how an AWK program is written. You can have the keyword begin followed by some statements. You can have a regular expression which might be present or not present, and some statements, and the keyword end followed by some statements. So how does this work? Begin means that the statements inside here, they are executed before any lines in this file that you want to process are executed. The regular expression means that if a line matches this regular expression, then these statements are run. If the regular expression is not existing, then the statements are executed on every language. You can have several of these lines in your AWK script. The end part here, it means that those statements enclosed in the brackets, they are executed after processing the entire file. AWK has a couple of variables. Notably, it has NF, meaning number of fields. We're going to have a look at this. It has NR, which is the number, the line number. It has ARGC for the argument counter. It's interesting enough, it's number of arguments plus one. And the argv, where you can put a number, means the arguments you pass to the scripts. This array here starts with the number 1 and goes to argc minus 1. How can you assign values to variables? You can say var equals value, or you can say var with the key equals value. How are arrays implemented? As a dictionary, where the keys are basically integers. You can also delete a key by saying delete the key on the var. How can you iterate? You can write a for loop like this. For example, for I equals 1, I less than 10, I plus plus, and inside the brackets you put the statements. This is very reminiscent of the C and C++ programming language. If you have a dictionary, you can also say for k, for the key in the var, and you write the statements inside the brackets. And if you want to test if the key is inside the var, then you say key in var. So it means the dictionary has the key inside. How do we define functions? With the keyword function and name, and followed by parameters. The parameters are separated by commas. What I put here with the arrows means that the parameters can be used for input and also for output. Inside the function, you can also return an integer or return a string. One of the important things to notice is that all the variables in AWK are global. This was a bad decision in the programming language, but it's stick there and it's not possible to change now. Anyways, this has an impact with the functions because all the variables that you are using and defining inside the functions will also be global. How can I have then some local variables? Because then I would not be able to do a reentrant function. Well, I can define a couple of additional parameters because these parameters will be local and the additional parameters that are here will be ignored, or you can discard them afterwards. It's not a pretty thing, but hey, it works. There are a couple of predefined functions that you can use in awk. One of them is, for example, the length of the string, gives you the number of characters. The substring, you can say a string, the start and the length, and it gives you a substring inside the string. You can find a needle in a haystack in a string, so you ask for the index of the needle in the haystack. You can split string, split into an array. This array is going to be the output, so here is the input, here is output, and the string is going to be split by the separator, which is again another string. You also have the printf and sprintf, so this is why the s is red. You may omit it. If you write sprintf, it returns a string, and if you write printf, it prints to the screen. The format is a typical format like what you do in C, and the arguments is also similar to what you do in the C programming language. Int of a variable basically gives you the floor of the variable. It cuts the floating part of the number and therefore gives you only the integer part, which corresponds to floor. You can call rand, which is going to give you a number between 0 and 1, 0 inclusive, 1 exclusive. And you can also seed the random number generator with srand. If you want to know the time, which is in an epoch in seconds, you can call sys_time. Here we can see the sub and gsub routines. Sub is to substitute, so we do string replacement on a regular expression. Means whenever we find a regular expression, we replace this with a REPL. The sub does it for the first match, the G is for the global, meaning that it's going to replace every time it finds the regular expression in the string. The gen sub is slightly different function, is going to allow you to use pattern capture, meaning you have a string, you have the replacement, but this replacement can use the \\1, \\2, etc. This would be for the first, second, third capture, which are the parts in the regular expression which are between parentheses. The how typically is just a string G, which means replace everywhere, global search and replace. How can I test with an if condition? If a certain string matches a regular expression, we can use the expression if string matches and regular expression, and we can use here the statements. Finally, what I would like to show you is how to call external commands and capture the standard output. In this case, we have a while loop. We write the command as a string and we pipe it to the function getLine and give it a variable. This variable is going to be called, so every time you have a new line, the variable p will have the new line. So here I'm going to do a printf, and with a percentage, well, this is %s, so we fix the slide on the spot, and the effect of this is just to print every line appending in the beginning this the symbol bigger than. Alright, enough of syntax, let's get busy and let's explore awk. So here I just started a terminal, and I'm going to need some data for awk, so I'm just going to type in ls-l. And you're going to see that there are a couple of things. So here total 6, there are some stuff here, etc. So what if we use this as a file and we want to see the only the file names? Well, I know ls gives me only the file names, but I want to use awk for that. So this is the data. Here would be the first column, the second column, third, fourth, fifth, sixth, seventh, 8th and 9th column. I hope I'm pronouncing this correctly. So let's pipe this into a small awk program and typically write this as a one-liner. So we just write the program between this thing here. Now, why do I open and close the brackets? Because you remember there was the matching of the expression, but I don't want to match anything, so we are just going to say, okay, I don't need to match, but for everything I'm just going to print the line. Okay, let's do this. So here it just prints back the line, or I can just say print column 6. And what is this? So 1 2, 3, 4, 5, 6. So we get the thing here. In the first line, there is no sixth column. And if this is the 6th, 7, 8, 9th. Okay, so let's type in 9. We could also have a small expression in the beginning. Let's say that number of fields should be equal to 9. Okay, so this is going to print the last field, the 9th field, when the number of fields is matching 9. Let's see. So you can see here there is a space. So this means this line here has no 9th column. And let's see how this goes. Okay, only the last one. So here only when 9 fields are defined, then we are printing the things. We can also do a kind of a string interpolation. Let's say here, add this here and put a comma. Let's try. Okay, so you see we add the bigger than sign. If we take this comma out, we just get the things together. So here we can also put, for example, number 1, and we would get the things here, and just to play around a little bit, get another space, and yeah, you see it gets the bigger than, immediately column number 9, followed by a space and column number 1. How cool is that? Now let's have a look again at the directory, and let's imagine that we want to sum up the values in this column. So we have column 1, 2, 3, 4, 5. So this is the 5th column. So let's just make sure that we are looking at this correctly. So the 5th column, and is exactly the value 3, 14, 840, and we want to sum up this thing. So what we can do is we create a new variable a and say plus equal 5. Okay, but well, nothing happens. Why? Because we are not printing anything. Do you remember we said begin and end? So at the end we can have another expression and we can just simply print a. And this is then the sum. Very cool, very simple. Let's try to get an if condition. I'm going to sum the values only if they are smaller than, let's say, 200. So we are going to get here if a less than 200, 100 is also okay. Then let's put some other brackets here. So the expression, again, it has to have 9 fields. This is the expression that is executed whenever the number of fields is 9. And then if a, sorry, there is a small mistake here. It's not a, if $5, if the value in column 5 is less than 100, then we accumulate this into the variable a, and at the end we print a variable a. So let's see, it's 17. 3 plus 14 is 17. Hooray! Now let's have a look at a different thing. Can we write this as a program itself? So as you can see, this is now starting to become a little bit complicated because the expression, well, we can still write this in the command line, but this expression is starting to become a little bit complex. Can we write a small awk program? Yes, we can. So I'm going to edit vim test1.awk, and now let's write a program again. So number of fields equals 9. All right, so now we rewrote the program as a text file. And now let's try to run the same thing, but instead of writing the program in the command line, let's call -f and test1.awk. And now we get another number, 80. And you might be wondering, well, why is it not 17? Well, let's see the directory. Well, ls-a. Lo and behold, there is a new program here called test1 we just created, which is 63. So it's less than 100 and it gets added. Let's try to correct that. Test1 less than 60. And we should get again the same value, 17. Let's see. Yes, we get 17. Now, for a little bit more of a complicated example, I decided to download some additional file. Let's see here. I went to the Open Database, Global Beer Characteristics dataset, and you can just download the sample data. Let's see this sample data. And it's a little bit complicated, and well, it's a CSV file, so it's a comma separated values file, and it has a couple of numbers, has a couple of things, so I'm not going to explore too much what they mean or not mean, but let's try to process this. So first thing is cat the sample data. Well, it comes here, it's a long file. Let's try to pipe it to awk, and again, let's write a very small program. Let's try to print the first column. Okay, it looks kind of okayish, but also a little bit strange. Let's have a look at the first line, head N1. So it says name, style, brewery, beer. Okay, so we have commas here that we would not like to have. What is happening here? Let's again open the sample file. Here we see that there is a space, beer name full. Okay, we actually are not separating on the commas, we are separating on the spaces. So we need to tell awk, you need to separate on the commas. This we tell in the command line by adding here -f comma. So please separate on the commas. Let's see. Well, now we have name. Let's instead of this print a 1, let's print number 2. Print a style. Let's so 1, 2, 3, 4. We want to see if the fourth parameter is captured correctly. Number 4. And lo and behold, beer name full. That is now correct. Are we still collecting all the data correctly? So let's see. It kind of looks, although we see some data here, which is looking a little bit strange. And why does this happen? This happens because some CSV files, they have spaces in the fields or have some weirdness in them, or maybe have commas that should not be part of the field separator. And there is a specification for the CSV format, and we need to tell awk actually that we are using a CSV file. So this is an option you're not going to find in a manual page, but well, it works. --CSV, and now let's see if this limited is going to disappear. Yes, it disappeared. So now it's taking things correctly. Let's I think it was column 8. Yes, column 8 also, you can see that things are looking pretty weird, but if we add the CSV, data looks much better. Okay, let's scroll a little bit. We have these things. Danger, don't set fs when CSV is in fact. Okay, let's not do that then, because it doesn't need to know about the comma. It's a comma separated value already, so we actually don't need this. So good that I looked at this. All right, so now if we want to sum up the things here, we could also do the same. Let's edit the test. Actually, let's copy the test one and let's edit this. We said before when the number of fields is 9, and now I have no idea how many fields there are, so I don't want this, and I just want to accumulate, and I just want to sum the 8th field, right? So, and at the end I'm going to print. I'm going to do another thing. Okay, seems that we are having some problems with getting the --CSV with the shebang. No problem, we continue. So in this case, I edited the file, so I just have user bin awk -sef, but I'm not going to use this. This is for some other cases. I'm just going to pipe it into awk. I can call also awk with the file directly, -f test1. And I get again 0 because, well, I need to get the --CSV. All right, that was a little bit of a doozy. Now let's try to print some other columns. Let's go for column number 9. Okay, so here we have some additional numbers, and let me try to see, I want to know which is the one that is the largest of these numbers, and I want to print a row with the largest number. So we have 2, this is definitely not, because we have a 10, we have a 13, a 23, etc. So let's look at the file here, and we're going to save this into the line. So actually let's take the val for column number 9, and now let's say if the value is bigger than a, I know a is not existing, it's initially set to 0, which is going to work, so initially it's 0, then what we're going to say is a is going to be the value, and the line is going to be $0, the entire line, and at the end I'm going to print the line. So this is the first line. If there are several lines with the same value, same maximum value, we are going to print the first match only. Let's try to run this again. All right, so yeah, there were some mistakes done previously, and let me show you what these were. So this is the point where we were at. And why were we getting some strange values? Well, this value is not plus equal. It should actually be equal to this one here. And the first column, well, it's text. And we are then here comparing two strings, which is not what we want. So we want to have here the integer value. So it's going to give 0 if this is a string. All right, so this should fix the problem. Let's now try to run it. Get the sample beer, and yes, we have the data here. And but we went through all this effort to get multiple lines if it matches, and therefore I'm going just to change the data here a little bit. I'm going to change one of the data points here so that it matches actually the maximum value in the column, and let's run the program again. Okay, now you see that it's actually printing 2 times. Okay, this is from debugging before, so let's remove that here and let's run again. And there we go. We have here this part. So we could pipe it again into awk with a CSV, and let's see what are the names of the beer. So print $1. So this is Ironworks Alt and Lighthouse Amber. Finally, let's write another simple program. So let's copy test1 to test2, and let's work from there. And instead of doing all these things, so we get the value that we are looking at, number 9. And now what I would like to see is a distribution of the values that we have. So I'm going to remove this and plot some histogram on the value. And here we are going to say plus equals 1. And here we're going to say for val in hist, print hist. Okay, let's do a printf %d, and let's add a comma d, and val comma ist on the val, and /n, and well, let's try. Okay, so we see that number 2 occurs 2 times, 22 also 2, 25 appears 3 times, etc. So, and the reason that we don't see the things looking that nice is we didn't really sort on the first value. So for that we can add a program sort, let's say -n for numeric, and we see 0 has 1, this is the header, 2, etc. until number 37 that has 2 values. Okay, so this video is becoming a little bit long, so let me show you the last program I wanted to show you. And instead of writing, I'm going to go through it. So this is the test.awk. And this program is to get dependencies on the FreeBSD port system. So, well, let's go first to user ports. Let's go, for example, to devel, and let's go to, I don't know, zil. It doesn't matter. And I'm going to type in make build depends list, and this is going to give me the dependency list to build this port. So it depends on the package, the CMake core, Ninja, whatever. And by itself, each of these packages is going to depend also on additional packages. So if I would like to have a list of packages that I want to compile, for example, that is needed in Poudrier or something like this, I would actually like to get a list of what I need to build and what I need to run recursively, because for example Ninja to compile is going to probably need some other things. So the Qt6 tools is going to need, or the Qt6 base is going to need some other packages, etc. And I don't want a list of the ports, but I want the names of the packages. So for that I can do a make capital V pkg name, and we get okay. In the currently it would compile to ZIL version 0.7.2. And yeah, I want to do this recursively. So, and do this with an awk script, because awk is awesome. So let's go here to a test file, and let's have a look at how I've done. So I defined a function that is called read dependencies. You have a command, and this is an input. This is an output, and here separated, this is typical in awk. If you put lots of separation, this means this is an internal variable, is to avoid to make the line variable a global variable. So this is a local variable. And let's see. So while command pipe get line, so I'm executing this command and getting every single line. And this is going to do the, for example, make build depends list. And for each line, I'm going to create an all dependencies and saying in a dictionary, this line is a dependency is equal to 1. I'm going to mark this as a dependency. At the end of the while loop, I just close the command. The main function is the function to collect all the dependencies, and this function uses the global variable tdeps, the total dependencies, and it takes in a dir directory, so, and outputs the tdeps in the global space. You see again with lots of spaces. So we have the build dependencies, the runtime dependencies, some local dependencies, and local dep, local dependency for a for loop that I need. So let's see. So I read dependencies. The command is built by changing to the directory dir and make build depends list. As we've seen before, I run it by hand. And again, I'm capturing in the variable. So this is the output. I'm going to read into the build dependencies. Here I have a small mistake. So this is R. cd dir to make, and now make run depends list, and I capture it to the variable run depends. Then I need to merge the two lines because some of the dependencies to build are going to be the same for running. So I get the unique values on the build dependencies, run dependencies, and this is going to be my local dependencies. Now I go over a for loop over the local dependencies for each dependency, local dependency. If this is not existing in the total dependencies of the package that I want to collect, then this is a new depend. So I don't want to visit dependencies I visited before. So if this is the case, then the first thing is marking it. Okay, this is one dependency that I need. I did not visit this before. I need, and now I recurse on the local dependency. So I do the collect on the LDEP. The unique values function is relatively simple. So you get dependency 1, dependency 2, and unique dependencies and a local variable v. For v in the dependency 1, mark the unique on v. And of course, the set, if you're setting 2 times the same value, it's just going to be the same. So it's a unique value at the end. Now, at the beginning, you need to give it an argument. Otherwise, it says it's missing the argument and just exits. Then it's the port name, or actually it's a port directory. It's argv1. And I collect on the port name. And this is going to populate the global variable tdeps. For each dependency in the tdeps, I go to this dependency, cd dependency, and make capital V package name, get a line, and print a line. That is pretty easy. So let's go again to the user ports devel, and I think I was at ZIL and tilde test.awk, and I'm going to say the package name is this one here. So yeah, let's try this. Takes a little bit of time. It's running. I have no idea what this program is doing, this ZIL, but you see that it has quite a lot of dependencies. So it has some graphical interface, so it requires Wayland, it requires Qt6, etc. Yeah, and these are all the dependencies you need to compile this program. It does take a little bit of time to get these dependencies because you need to execute lots of commands, but well, you have all the dependencies. That's pretty cool. That's it for today. If you liked the video, please give it a thumbs up. And if you have some comments or suggestions, please use the space down below. Thank you for passing by. Have a nice day, take care, and see you next time. Bye bye.